This is one of my favorite things about algebra is coming up with the quadratic formula. Because right now, if you look here, this is just the standard form of a quadratic equation. It's the general standard form of a quadratic equation. And what we're going to do is we're going to use what we learned over the last couple of days to solve this equation for x. Basically, what we're doing is we're starting off by kind of doing what we did yesterday, where we're going to complete the square. So for example, if we don't know what C is, so we can't assume that C is a perfect square, which means we got to get rid of it, right? How would we get rid of C? Subtracting it, yeah. So everybody write this down. Subtract C from both sides. Minus C, minus C. C's are going to cancel. And then I can write a lot bigger now because that'll make it a lot easier. So that'll be ax squared plus bx equals negative C, or the opposite of C. So we don't know that C is a perfect square, so we have to move it over. We also don't know that A is a perfect square either. And because we don't know that A is a perfect square, whether it is or isn't, that means we have to eliminate A as well, but we wouldn't be able to subtract A because it's attached by multiplication to x squared. So how would we get rid of A? We would divide. So divide everything on both sides by A. Now in front of the x squared, the A's are going to cancel. So that's going to give us x squared plus, I'm going to write b over a with the x after it like that. And that's going to equal the opposite of C divided by A. Now, x squared is a perfect square. We know that. And we also know that if we take half of this and square it and add it to both sides, that would complete the square. So what is half of b over a? Let's move over here for a second. Half of b over a is b over a times 1/2, which would be b over 2 times a. Half of something just means multiply it by half. If you multiply b over a by 1/2, 1 times b is b, a times 2 is 2a. So we're going to add b over 2a squared. We can't forget that we have to square this on both sides, but we're not going to write b squared over 4a squared. We're going to use parentheses around it. So on the left, we're going to say b over 2a squared. We're going to add that. And on the right, we're going to add b over 2a squared, like that. Because we're completing the square. This value completes the square. It should go after the b over a times x, which we'll do that when we rewrite the next line. All right, so now we're going to have x squared plus b over a times x plus b over 2a squared. Like that. We're completing the square. This is the same thing that we did over the last couple of days. The only difference is like we don't really have numbers so much. It's just a lot of variables that we're dealing with. Now, on the right side, we got to add these two things together. So I'm going to go ahead and we're going to do a little bit of work off to the side here. So I'm going to take this. I'm going to scoot over here. And let's see. I'm going to flip around the order here just because with the quadratic formula, it'll make more sense if we do it that way. So we're going to say b over 2a squared plus opposite of c over a, or minus c over a, however you want to think of it. So in order to do this, we are going to have to multiply out the b over 2a squared. So if you square the top, you get b squared. If you square the bottom, you get 4a squared. So we're just going to apply that squared to everything on that particular term. So that's b squared over 4a squared. And instead of writing plus negative c over a, I'm just going to write minus c over a. Because subtraction is the same thing as adding a negative or adding the opposite. So we can just make that a little bit easier, get rid of the plus and just make it a minus. Now, in order to add or subtract fractions, what do you have to have? You need a common denominator. Right now, we don't. This one's 4a squared, that one's a. But we're not too far away from a common denominator. What can we multiply this denominator by to make it equal that one? 4a, right? We already have one factor of a. So if we multiply by another factor of a, that would be a squared. And we also need the 4. So if we multiply numerator and denominator here by 4a, that will give us the common denominator of 4a squared. So we're going to get, and then we can write everything over the same denominator. So that's going to be b squared minus c times 4a. If we rearrange this, putting the number first and then go alphabetically, that would be minus 4ac. And then it's over 4a squared because we have a common denominator. So now we can take this and put it back here. That's what the right side of the equation equals when we add those things together. So that's b squared minus 4ac over 4a squared. All right. Now we can factor the left side. We can factor the left side to basically what's inside the parentheses here. So we're going to say x plus what's inside the parentheses, and then square. So that'll be x plus b over 2a squared. Because this is the square root over here. We never squared it in the first place, so that is the square root. And so it's the square root of x squared, which is x, the square root of this thing if we squared it, which is the thing in those parentheses. So we add it to it, and then it ends up being squared, perfect square trinomial. And this is still equal to b squared minus 4ac over 4a squared. What's our next step once we factor the left side? What do we usually do? If we're solving, what's our next step once this side is factored? Square root, yeah. So we're going to square root the left. And when I square root the right, I'm going to square root the numerator and the denominator separately. It's the same thing as square rooting the whole thing. But the reason why I'm doing that is because the numerator itself is not a perfect square, but the denominator actually is. The square root of 4a squared is the denominator of this one over here, 2a. So that's why I'm doing it second. So if we square root the left, we're just left with the stuff inside the parentheses, which is going to be x plus b over 2a. And then on the right, the denominator is going to be 2a because the square root of 4 is 2 and the square root of a squared is a. And the numerator, that doesn't square root, so it's going to remain in the square root. We also need our plus minus symbol though. So plus or minus the square root of b squared minus 4ac. Does anybody remember what the quadratic formula actually is? Because we're about to get there. We're almost there. To get x by itself, what do we have to do? Subtract that fraction. Yeah, minus b over 2a. So if we subtract b over 2a from both sides, those will cancel. And, oh, take a look. Are those common denominators? Those are common denominators. That's really convenient. Okay, so that's going to give us x equals the opposite of b, and then combine it with the rest of that numerator, plus or minus the square root of b squared minus 4ac over the common denominator of 2a. That's the quadratic formula. So the thing that you learned a couple years ago in Algebra 1, and we're probably never told why it is what it is. You were told, hey, this will solve any quadratic. Now you know why. Because if you start with a standard form of a quadratic equation and you solve for x, you literally get the quadratic formula by solving for x. And that wouldn't have been shown to you a couple years ago because you didn't know completing the square then, but now you know completing the square. So hopefully it makes a little bit of sense. You don't need to memorize this in any way whatsoever. I just really enjoy showing why we end up getting the quadratic formula, what it comes from. Now you know where it comes from. So this question here at the bottom of the warm-up should hopefully be a pretty straightforward question. Why is there a plus minus in the second to last step for deriving this formula. Deriving just means coming up with. So why is there plus minus here? Because we're square rooting, exactly. When you square root something, there's a positive and a negative root. Yeah, cool. So let's start using this again. So flip the page over. Now, the quadratic formula, actually, let's just go ahead and write off to the left here, quadratic formula. All right, now off to the left, let's just write it down. X equals the opposite of b plus or minus the square root of b squared minus 4ac. That whole thing gets divided by 2 times a. So the only thing we need to do to solve the quadratic formula is go to your equation, figure out the values of a, b, and c, and substitute them in for that. That's basically all that needs to happen. And then we can just use our calculators after that to figure out the answers. That's mostly what we're going to be doing today. There will be some nuance with that because it's possible to get imaginary numbers now, which was not a thing a couple of years ago. But let's go ahead and start working through this. So standard form of a quadratic equation says ax squared plus bx plus c. So we need to use the values of a, b, and c. So what does a equal here? 2. What does b equal? 6. And what does c equal? 3. So what we're going to do is just drop those values into that formula. And then we'll basically just use our calculators to have it solved for us, which will be great. Like I said, there will be some exceptions, and I'll let you know when those exceptions happen. But for the most part, if you can use the calculator correctly to do this, it's not too bad. So we're going to say x equals, let's see, b, opposite of b would be -6, plus or minus the square root of b squared. You can write 6 squared, or if you know 6 squared is 36, you can just write 36. It's up to you. I'm going to write 6 squared. And then minus 4 times a, which is 2, times c, which is 3. Then we're going to divide that by 2 times a, which is, I mean, it's 2 times 2, so you can just write 4 on the denominator if you want to as well. If you want to do some mental math before you actually, write it out, that's fine with me. So generally speaking, a lot of the times you'll get 2 answers because of the plus minus. Sometimes you'll only get 1 answer. Sometimes there won't be an answer in terms of real numbers. And if that's the case, then we need to not worry about, but we have to figure out what's going on with our imaginary values and things like that. We can't just say no solution like we did a couple years ago, because now we have imaginary values. So what I want you to do here, on your calculator, open up a fraction. So click the button that says math over on the left, right underneath alpha, push math. Scroll over on the top to where it says frac for fractions. Click on the first one, n over d, which stands for numerator over denominator. And we're just going to type in everything on the numerator. Now, unfortunately, these calculators do not have the plus minus button, so we're going to have to do it twice. But there's a really easy way to do this twice without having to retype the entire equation. So I'll show you that as well. So let's start with the plus version. So -6, make sure you use the negative button, not the minus button here. The negative is by the decimal, so -6. And then we're going to add. Now we need the square root, and the square root is going to be right above x squared. So push second, the blue button, and then the x squared button. That'll open up the square root. And then we're going to type in 6 squared, or if you just want to write 36 instead, that's fine. This time we're going to write -4, not -4, but -4. And then you can use the times button, or you can just type it in exactly like I wrote it using parentheses. Either way is fine. So parentheses 2, close it up, parentheses 3, close it up. And then on the bottom is 2 times 2, or if you just want to write 4 on the denominator, that's fine as well. So if we get this answer, we end up with about -0.63. Now, there's a couple things we can do here. I'm going to take a look at your assignment real quick, just to make sure the types of problems or the types of answers that this book is looking for, because a lot of the times the values of x are not written as decimals. Lots of times they are written as fractions, which we're going to go ahead and do that. We're going to write our answers as fractions. So as a decimal approximation, we get about negative 0.63. Now, the thing we're going to need to do here is actually write this out as a fraction. So the way that we need to do that is let's figure out what's going on underneath our square root here. So that's going to be 36 minus 4 times 2 times 3. So what you can do is just calculate what's under the square root here. So 36 is 6 squared minus 4 times 2 times 3, which is 12. So if we rewrite this, this is going to be x is equal to negative 6 plus or minus the square root of 12 over 4. And if we can simplify the square root, we should, and we can, because the square root of 12 has a perfect square factor. So the square root of 12, let's go ahead and just going to talk about this for a second. Square root of 12 is equal to the square root of 4 times the square root of 3, because 4 times 3 is 12. Everybody good at that? What is the square root of 4? 2. So this is going to equal 2 root 3. The square root of 12 reduces to 2 root 3. So this is going to be x equals negative 6 plus or minus 2 root 3 over 4. We got one more step. We're almost done. Not too much to do here. So negative 6 is separate from the 2, but the 2 is multiplying by the root of 3. So if we look at our integer values on the numerator, negative 6 and 2, if both of those can reduce with the denominator, we should do that. Negative 6, 2, and 4 all have a common factor of what? 2. So that means that all three of these values can be reduced by a factor of 2 to get our final answer. So the answer is going to be x equals negative 3 plus or minus the square root of 3 over 2. That is our answer for the first exam. And your book is going to be asking you to write the answers in what we call simplest radical form. So basically reduce them to that. All right. Let's try the next one. So any questions here before we go to number 2? Or part B, I should say. No, number 2. No problem. Yeah. So as a fraction, that's all we need to do. So we don't need a decimal value at all. If you want to calculate the decimal value of this to verify that it was the same as the one that we got before, feel free to do that. That's a good way to double check your answer. But it's not something you have to. So as long as you get to here, you're good. Basically, it's like reducing a fraction and writing it in the simplest form as a fraction. That's what we're doing. All right, let's try B. I'm going to speed this up a little bit for B. Here we go. A equals 3. B equals negative 2. C equals 7. So there's our values of A, B, and C. All right, X is equal to the opposite of B. B is negative 2, so the opposite of B would be 2. Plus or minus the square root of. Here we go. I'm going to consolidate some things this time. I'm going to speed this up using a little bit of mental math. Negative 2 squared, negative 2 times negative 2 is positive 4. So it'll be 4 minus 4 times 3 times 7, because that would be minus 4 times A times C. All divided by 2 times A, which would be 2 times 3, which is 6. It just kind of speeds it up if you do a little bit of mental math to kind of help yourself out there. Now, what is 4 minus 4 times 3 times 7? Let's type that in. 4, figure out what's underneath the square root. 4 minus 4 times 3 times 7. I get negative 80. So underneath our square root, we got negative 80. So that's x equals 2 plus or minus the square root of negative 80 over 6. Now, if you type that into your calculator, it's going to say error, some kind of a domain error or no real solution or something like that. Which means that even if you wanted to use your calculator to solve this one, you couldn't. But we can solve it because we can square root negatives, where our calculators are saying, I can't do that because there's no real solution, which is true. There is no real solution, but there is an imaginary solution. So let's figure out how to reduce this square root of negative 80. So the square root of negative 80, head on over here. Is going to equal the square root of 80 times the square root of negative 1. Get rid of the imaginary unit first of all, because then you can just figure out how to simplify the square root of 80. So what is the largest perfect square factor of 80? A factor of 80 that square roots. If you have your multiplication table that I handed out a couple weeks ago, that might be useful. Eighty is definitely divisible by 4. So 4 is definitely a perfect square factor of 80, but it is not the largest perfect square factor of 80. What's that? What number? 40 is a factor of 80, but 40 is not a perfect square. Same. 20 is a factor, but 20 is not a perfect square. Because if you square root 20, you don't get a whole number, right? So try to think of some other ones. What else is 80 divisible by, where one of the factors is a perfect square? It's not one that you might know right off the top of your head. That's why I'm suggesting if you have that multiplication chart, could be a good thing to check in on. Or if you think of it this way, if 4 is a perfect square factor of 80, which it is, what is a multiple of 4 that is also a perfect square? 16. 16 times what equals 80? 16 times 5. Cool. So this is going to be the square root of 16 times the square root of 5 times I, which is going to be 4I root 5. Square root of negative 1. What's that? Factored it out of the square root of negative 80, because 80 times negative 1 is negative 80. So negative 80 doesn't square root to be a real number, right? You can't square root a negative and get a real number answer. So this is like what we learned a few days ago with the imaginary numbers. Anytime you square root a negative, you have to factor out a factor of negative 1 from that number, so you can actually reduce this square root. And then this is equal to the imaginary unit that we learned about a few days ago. So square root of negative 1 is I. Those two things are interchangeable. And so this is basically treated kind of like a variable that we just use with it. So we can take this, we can factor it out because negative 1 times 80 is negative 80. So we just divide it out like we would regular numbers, but with square roots over. And then once we do that, we can reduce this square root like we normally would by finding a large perfect square factor of it. 16 is 5, square root of 16 is 4. So it'd be 4 root 5. But then we also have the square root of negative 1, which is I, so that makes it 4I root 5. So we're going to put that on our numerator next to the 2. So that'll be x equals 2 plus or minus 4I root 5 over 6. And then the last thing we need to do, once again, is look at the number in front of the plus minus, look at the number outside our square root over here, and look at the denominator. Can we divide all three of those numbers by the same thing? Yeah, what? 2. All right. So we're going to get x equals 2 divided by 2 is 1, plus or minus 4 divided by 2 is 2, so that'll be 2I root 5, over 6 divided by 2 is 3. So you get 1 plus or minus 2I root 5 over 3. Any questions about that before we continue? Yeah, Carla. How did it go in front of it? Just because in terms of okay, so everything's being multiplied together. It's technically 4 times the square root of 5 times I. And so when it doesn't matter the order that you multiply in. And so generally speaking, when you write it out, it's just a format thing. It's not like a mathematically correct versus incorrect thing. But format wise, you will always see a number, and then you'll see either a variable or something equivalent to a variable. And then you're going to see the radical at the very end. So that's just kind of an order. So anytime you simplify a negative root, you're going to get the whole number that square roots. You'll get the imaginary unit directly after that, and then you'll get whatever's left over under the radical. So that's generally how that. So, oh, Colby. Take over. All right. Okay. So, does that kind of help a little bit with your question? All right. Yeah. Hold on. What's that?
Why didn't you divide by 5?
Because these are all connected by multiplication. And so when you simplify, you're only simplifying the integer. The square root, this square root doesn't divide by 2 anyway. I mean, technically we did divide it by 2 because those three things together account for one number. Yeah, that's one number. Yeah. And so that one number, because that one number has an integer that's divisible or has the same factor as something on the denominator, we're allowed to do it that way. Yeah. Okay. Any other questions before we look at example 2? All right, example 2. Solve the equation using the quadratic formula and another method. We have 2 other methods aside from the quadratic formula. We have solving by factoring, and we also have solving by completing the square. So first of all, let's just use quadratic formula, and then let's pick another method after that. So let's see, A equals 6, B equals 1, C equals -15. And so that's going to be x is equal to the opposite of b, so -1 plus or minus the square root of b squared. 1 times 1, that's 1. That's easy. So 1 minus 4 times a, which is 6 times -15. All divided by 2 times a, which is 2 times 6, so that's 12. All right, let's see. -4 times -15 is 60. 60 times 6 is 300. So that's 361, I think, underneath the square root. Just going to double check here. -4. Or actually just 1 minus 4 times 6 times -15. Yeah, 361. Okay. So that's x equals -1 plus or minus the square root of 361 over 12. Does the square root of 361 have any perfect square factors? What's that? Let's see. It's divisible by 19. Oh, it actually is a perfect square. 361 is a perfect square. That's nice. It's 19 squared. Wow, that's convenient. Okay. So that means x is equal to -1 plus or minus 19 divided by 12. Now, we're not done with this one because there's no square roots left here, which means we can just get regular numbers for our answer because there's no square roots left. So we're going to end up with 2 different answers. We're going to say x is equal to -1 plus 19 over 12. We're also going to have x equal to -1 minus 19 over 12. If all you have left are integers, if there's no roots left, if there's no imaginary values, split them apart and actually figure out what those fractions are equal to, or better yet, whole numbers if they're whole numbers. So let's see, -1 plus 19 is 18. 18 and 12 are each divisible by 6. So that's going to be 3/2. For that one. I mean, over here, -1 minus 19 is -20. 20 and 12 are each divisible by 4. So that would be -5/3. So we should get 3/2 and -5/3 for our answers to this one. Now, the other way that we can do this, we could either use, here's the thing about factoring. Not everything is factorable. So there's no guarantees that if you try to use factoring, that factoring will work. However, completing the square will always work, but completing the square is a little bit more challenging than factoring. But we know that completing the square will work, whereas factoring may or may not. Here's something that you can know. If these numbers here are regular fractions and they don't have any imaginary values and they don't have any square roots in them, that generally means that the original function or the original equation is factoring. So let's go ahead and try factoring this. So we're going to get, let's see, 6x squared plus x minus 15 equals 0. So we're going to go ahead and use the slip and slide method. That means we're going to start off by multiplying the first number times the last number. What is 6 times negative 15? Yeah, negative 90. Good. So x squared plus x minus 90 equals 0. Give me two numbers that multiply to negative 90 and add to positive 1. By the way, anytime two numbers multiply to a negative and they add to either positive or negative 1, that tells you the factors are only 1 away from each other. Yeah, negative 9 and positive 10. Nice. So we got x minus 9 times x plus 10 equals 0. Now we can't forget here, I actually forgot to do this with my 5th period yesterday. I teach an algebra 2B and I was using slip and slide. By the way, you're not going to stop factoring. We were using a slip and slide factoring and I forgot to divide these by the value of a and it just messed up the entire problem. So don't forget to divide those two values by the original value of a in order to complete this problem. So those are each going to divide by 6. And then we can reduce those fractions. 9/6 would be equal 3/2. So that'll be x minus 3 over 2 times x plus, those both divide by 2. So that's going to be 5 over 3 equals 0. And then to complete the slip and slide process, we have to take our denominators and then move them in front of each variable inside each set of parentheses. So we're going to get 2x minus 3 times 3x plus 5 equals 0. That is the factored form. Factors nicely. Now, in order to solve, we're going to take each set of parentheses, set equal to 0, and solve for x. So we're going to have 2x minus 3 equals 0. We're also going to have 3x plus 5 equals 0. And we're going to solve each of those very quickly. These are just two-step equations. So on this one, we'll add 3 to both sides. That'll be 2x equals 3. We'll divide by 2, and x equals 3/2, which is what we got over here. That's one of them anyway. The other one, subtract 5 from both sides. 3x equals negative 5. Divide by 3, x equals negative 5/3. And what do you know? Same two answers. It does not matter which method you use. You should end up with the same answer either way. There's no guarantees, though, that something will be factorable. So unless you know it can factor, I wouldn't suggest using factor. Yeah. Opposite. Yes. If you're going to factor it, I would appreciate finishing the factoring process. But if you know that the answer is going to be opposite of those, you could just go straight from here to the answers. I'm fine with that. Yeah. Which makes sense because we're trying to figure out what value of x makes this set of parentheses equal to 0. And since we have this here, the opposite of that would make this equal to 0. So yeah, that's why. All right, questions there? Cool, let's keep going. We've got 2 more examples. Well, actually, you know what? We might have to finish this on Monday. Not a big deal. All right. So this next part, we're going to be taking a look at how this stuff works with graphs. And we're going to be talking about something called the discriminant, which is something that you learned in Algebra 1. And I'm just going to go ahead and remind you that the discriminant is the thing that is underneath the square root symbol. So, for example, we'll talk about these graphs in a little bit more detail in a second, but these right here, those are all the discriminants. The stuff under the square root is the discriminant. And the value of what's under the square root, b squared minus 4ac, whatever that value is, determines how many solutions there are for each of those quadratics. And a solution, just in case you forget, a solution to a quadratic, it just tells you where the parabola crosses the x-axis if it crosses the x-axis. So for example, this first one here, 2x squared minus 7x plus 3 crosses the x-axis in two places. It crosses at 7 plus 5 over 4 and 7 minus 5 over 4, whatever those fractions end up equaling. But it crosses the x-axis in two places. The value of the discriminant underneath the square root is a positive number. So the radicand, the value under the square root, is a positive number. And so if the square root value in a quadratic formula is positive, there will be two places where the parabola crosses the x-axis, meaning you're going to get two answers, two solutions. By the way, that's right here. Everything is summarized at the bottom here. If it equals 0 underneath the square root, like this one, that means there is one point of intersection with the x-axis. It doesn't mean it has to face up either. It can face upside down. But there's one place where the parabola meets the x-axis, which means the vertex is on the x-axis. Whether it's facing up or down, that's the vertex. And then the last one here doesn't come into contact with the x-axis, which means there's no real solution, which means there are imaginary solutions. But if there aren't any real solutions, that means that what is under the square root is negative. So positive, 0, negative. Two solutions, one solution, no real solutions, which means imaginary solutions. So if you have like a highlighter or something, or if you just want to circle something, first of all, the discriminant is the value of the radicand. The discriminant is the value of the radicand b squared minus 4ac. If the discriminant is greater than 0, if it's positive, two real roots, or you could say two answers, two solutions. Actually, two real solutions. If the discriminant is equal to 0, one real solution. If the discriminant is negative, two non-real roots, which means two imaginary solutions. That's what we're dealing with. So if you are asked to describe how many solutions something has, you do not need to solve the entire quadratic formula. All you have to do is figure out what's underneath the square root. If it's positive, there's two real solutions. If it's 0, there's one real solution. If it's negative, there are two imaginary solutions, which means there's no real solution. So that's what we're going to do for the next one, A and B. These will be very, very quick because we're not actually solving the entire quadratic formula. So for A, here we go. All we have to do is figure out b squared minus 4ac. That's it. So b is 8. So that means b squared is 64. Minus 4 times a, which is 16, times c, which is 1. 4 times 16 is 64, times 1 is still 64. So that would be 64 minus 64 equals 0. The value of the discriminant is 0. How many solutions are there? What type of solutions are there? One real solution. Good. That is all you have to do for a problem like that. Very quick. Do the next one on your own. sports going on today. All right. Okay, in the interest of time, let's take a look. So let's see, b squared would be 25 minus 4 times 2 times 6. Let's see, 6 times 4 is 24. 24 times 2 is 48. That's going to be 25 minus 48, which would be what, negative 23? Okay. How many solutions? What kind? 2 imaginary solutions. Good. I'm just going to abbreviate imaginary and solutions. And you're welcome to do that as well. There we go. The discriminant is negative. 2 imaginary solutions. We don't know what they are. We just know that, first of all, the parabola itself doesn't cross the x-axis. And there's 2 imaginary solutions. This one, the vertex is on the x-axis. We don't know where it is. We just know that's what it is. Questions here before we look at example 4. All right, flip it over. Let's keep going. Words. Look at all these words. Okay. Talking about tennis. Any spring tennis players here? Tennis folks? Yeah, 1, 2-ish. Okay. 1.5. All right. So here we go. We're interpreting the discriminant. So again, it tells you, hey, we're going to use the discriminant. It says Rachel is about to serve and tosses the tennis ball straight up into the air. The height h of the ball in meters at time t in seconds is given by this. So basically, the ball reaches a height after a certain amount of seconds. Okay. Will the ball reach a height of 4 meters? To see if h equals 4, so basically to see if h equals 4 for a value set of t, set the quadratic expression for h equal to 4 and solve. And then rewrite the equation in standard form. Okay, so let's go ahead and do that. So we're going to write 4 equals, actually, you know what? I'm going to flip it all around. Negative 5t squared plus 5t plus 2 equals 4. So we're just plugging in 4 for h. That's all we do first. And then rewrite it in standard form. What that means is set it equal to 0. So basically subtract 4 from both sides. So that's going to be negative 5t squared plus 5t plus, or not plus, minus 2 equals 0. Because we subtracted 4 from both sides. So basically what we're trying to figure out is, so by the way, height of 4 means that the y value is 4. And so if we set it equal to 0, we're still figuring out if it reaches a y value of 4. Now, there are 2 possibilities for y equaling 4. And there's 1 possibility for y not equaling 4. And we're going to use the discriminant to figure that out. So the discriminant here is going to be b squared, so that's 25, minus 4 times a, which is negative 5, times c, which is negative 2. Negative 4 times negative 5 is positive 20. Positive 20 times negative 2 is negative 40. So that's 25 minus 40. What's 25 minus 40? Negative 15. The discriminant is negative. Does it reach the value of 4 that we were talking about? No. Because in order for it to actually reach a value of 4 on the height, we basically reset it. So it went from 4, we reset it to 0. So basically we're kind of like, we're falsely changing where that x-axis is. We're resetting 4 to 0. So now the x-axis is here. And if it doesn't cross the x-axis, that's negative, that means it didn't reach a height of 4. If it was positive, it would have gone above 4 feet and then back down below 4 feet because there'd be 2 answers. If it was equal to 0, it would have peaked at 4 and then come straight back down. So the height would have been 4, the maximum height. But it didn't even get that high. So the answer is no. So because the discriminant is negative, the ball did not reach a height of 4 meters. We're talking about meters here too. We're not talking about feet. 4 feet, it would be ridiculous if it didn't get above 4 feet because you probably released it at a higher point than 4 feet to begin with. 4 meters. So we're talking at like 13 feet-ish. So I abbreviated a lot here too, because, you know, we don't want to write too much in that. Yeah. So it depends on what the value is here. So if this was either 0 or positive, then the answer would be yes. Because we're talking about the value of the discriminant. How many solutions are there? How many times is it across the x-axis? And so we basically reset the x-axis from 4 to 0, using 4 as the number that we need. And so by getting rid of that, we're kind of adjusting the entire height of the graph. And so if the discriminant is positive, that means that the ball reached a height of 4 meters. It went above 4 meters and then came back down because there's two answers if the discriminant is positive. If the discriminant is 0, that means it went up, reached a maximum height of 12, and then came back down. 12 meters, 4 meters, sorry. Maximum height of 4 meters, came back down. But because it's negative, it went up into the air. 4 meters is up here. It was below. It never actually reached that height. If it was 0, that means yes. But it means it would have been exact, like the maximum height would have been exactly 4 meters. If it was a positive value, that means it would have been, the maximum height would have been more than 4 meters because it would have gone above 4 meters and then back below it again, because a positive number for a discriminant means 2 solutions. Cool. All right. So this next one. As she begins to serve, Rachel tosses the tennis ball up. Okay, height of the ball in meters, time 15 seconds, blah, 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 blah. Same function, does it reach a height of 3 meters? So it's the same question, but we're using 3 instead of 4. So if you want to write this function again and then subtract 3 from both sides, you can, or you can just take away 3 from 2 and say -1 instead, which is what I'm going to do. -5t squared plus 5t minus 1 equals 0. So basically the value of c changes from -2 to -1. That's really the only difference between example 4 and the trial 4. And so we'll do the same thing. That's going to be 25 minus 4 times a, which is -5, times c, which is -1. Now, first of all, we know that this ball does reach a height of 4 meters or 3 meters, because if we take the discriminant here, we get a positive number, don't we? 5. Okay, good. So 5. Now, that wasn't the question, though. This proves that the ball did reach a height of 3 meters, and it happened twice, right? Because it went above, because this is positive, it went above 3 meters, reached its maximum, then came back down below 3 meters again. And so it's saying, when will the ball reach a height of 3 meters? So that means we actually need to solve the problem using the quadratic formula. Now, the nice thing is we've already figured out what's under the square root. So we can say t equals the opposite of b, -5, plus or minus the square root of 5 over 2 times a, which is -10. So we're using the quadratic formula. We've already figured out what's under the square root, though. So that's this number here. We just plug it in here. There's the opposite of b. There's 2 times a. All right, so let's figure out when the ball reaches a height of 3 meters. So on your calculators, I'm going to say -5 plus the square root of 5. That equals -2 point, whatever, divide by -10. That's about 0.28. Okay, so one of our answers, we'll say t, about 0.28. Now, why am I using a decimal here when I said before we usually keep our answers like this? Time, yeah. This one has context. If we're talking about time, probably not going to answer it like this. That's a little bit weird. If you're to answer a question, how long did it take? Well, it took -5 plus square root of 5 divided by -10 seconds. What is that? Nothing. But well, it isn't nothing, it's that. But this makes more sense if you're talking, right? So now let's do the same thing. We'll do -5 minus the square root of 5, because there's 2 answers. And then when we're going to say enter, we'll divide that by -10. Oh, that says 0.72. So here's the question. Both of those numbers are positive, which means both of them are valid. So which one is the correct answer? Because there's only one answer. Read the question again, then tell me which one of those is the actual answer. Yeah, that one. Because this question is asking, when she tosses it, how long will it take for the ball to reach a height of 3 meters? And that would be the first value. This is when it comes back down below 3 meters. So 0.28 peaks, comes back down, then at 0.72 drops back down below 3 meters again. So the first one is the one we want. So that means it took about 0.28 seconds for the ball to reach a height of 3 meters. Okay. How do you verify it? You can graph it. That's a great question. How do you verify? So I would say verify by going to your graph and typing in negative 5x squared. Yeah. Negative 5x squared plus 5x plus 2. Go to your graph. Ooh, that's really bad. I need to redo that. Zoom, standardize that thing. There we go. Okay. So what we're looking for is a height of 3. Actually, yeah, we're looking for a height of 3 meters here. So you could do this function here. Actually, I would recommend using that function instead, because this is the one that actually puts the stuff on the x-axis that we need. So I'm going to go back to my y equals. I'm going to change the +2 to a -1. Go back to the graph. There we go. Both of our intercepts are greater than 0 at this point. So I'm going to zoom in just to get a little bit better. There we go. Okay. So I graphed this function here because that's the one that actually puts the height of 3 meters at the x-axis instead. So then we can go to calculation, second calc. We'll go to 0. We're figuring out the 0 of the function where it crosses the x-axis. Lower bound is here. Upper bound is here. Enter and enter, and there it is, 0.276, which is that number right there, 0.28, where it first goes above a height of 3 meters. So you can, how to figure out that number? How do I 0? Oh yeah, so hit second, and then trace, which is the calculation menu, and then go to 0. So you're figuring out where the line crosses the x-axis. It's going to ask you for a left bound. So that means you want to go left of the point of intersection with the x-axis. So basically underneath the x-axis, hit enter, and then pick a point just above it. Hit enter again, and then it's going to say guess, and then you hit enter again, and it'll give you the answer. Yeah? No? What's it saying? What's that? Error. We'll figure it out. All right, so we're going to go ahead and stop there for the day. We're going to have one more example that we're going to have to finish up on Monday. Let's see.